So about 2 years ago, a friend contacted me with an idea for a grip implement, a sleeve that would slide over the handles of a sledgehammer and have knurled handles like a gripper. It was this, the Sledge Gripper Sleeve. This is the picture that he sent to me too. Now initially I didn't give it much thought, and I was rather misguided about the importance of sledge leveling, but now I realize that it is a really good idea, so I have to give credit where it's due. Thanks, Nate. And I also want to thank Aaron at Corcoran Training Systems for machining the handles that were so important in this project. Now when I asked Aaron to make these, I knew that they would come out perfect, but I had no idea that their look and function would be absolutely impeccable. He truly outdid himself on this project, and I'm really happy that I had Aaron work on it for me. At the risk of making things too confusing, I do want to go ahead and explain my idea for this project and how I went about it. I imagined a base plate that the handles would be attached to, and then a perpendicular line extending from that base plate. I wanted to know what angle would be made between the handles and that perpendicular line to most closely represent gripper handles when they're closed. So after some measurements and a little bit of math, I determined that that angle is 4.2 degrees. There are two reasons for having the handle set into that base. Number one, for strength. And number two, because aluminum transmits heat really efficiently, and I knew that if I welded right next to the knurl, I would probably ruin it. The holes are set at the proper width of gripper handles when they are closed, and they're also offset slightly. And that's because gripper handles are offset slightly. But you'll notice, the offset that I went with was not as much as a real gripper, because I thought that it might be too awkward to hang on to. Now in order to achieve the 4.2 degree angle, I propped one side of my vise up, sort of like a sign table. Now it's not funny, it's serious, it really worked. Sometimes you gotta do what you gotta do. Now as a rule with aluminum, it needs to be cleaned when you weld it. But since I've drilled the holes and I used oil when I drilled them, I'm definitely going to wipe these down with acetone. Acetone is bad for you, so make sure you wear the proper gloves. And of course I wiped down the handles that Aaron supplied to me, but I was very pleased to find that they were not dirty at all. So once everything was cleaned up, I just made a very simple fixture here to hold things in place for me so I can get some tacks. Now I had to be conscientious of where I put the tacks because I did not want to interfere with the welding of the handle to the base plate. And I also know that welding is going to create a heat affected zone that will make it more difficult to work with later on in the project. The handles of course are 3/4 inch solid aluminum. My machine is a 200 amp machine, so that is pretty much pushing the machine to its limits, but I was able to get the job done. Just a few small tack welds to keep everything from moving around on me as I work on the rest of the project. For the head of the hammer, I decided to put these squares on the end. That way, if you do brain yourself, it will be blunt force trauma and not a puncture wound. Getting good arc shots is really challenging. Always fighting lighting issues, getting the camera to focus, or finding a spot where you can see and the camera can also see is a real challenge, but I hope you can see what's going on. Now my dad always said to make sure that you charge more for round parts, especially really small round parts. And if you think it's rude to charge more for round parts, just remember that machinists always charge more if you want the parts to be round. You know, it's always a struggle to find a way to fix your parts, but it doesn't have to be complicated. This is a really simple setup, and it did exactly what I needed it to do to hold things in place. Now, unfortunately, I deleted several videos that explain more of this build, but I think you get the gist of what's going on here. So why did I make this out of aluminum? I normally don't work with aluminum. Well, there's quite a few reasons. Number one, the handles that Aaron made were made out of aluminum, and while I could have mechanically attached them, I didn't want to do that. I wanted to weld them. Another reason is that aluminum is really light. A hickory sledgehammer handle, just like this one, weighs 1.5 pounds. The sledgehammer made completely out of aluminum with the knurled handles weighs 1.6 pounds. So I believe the balance between this and a real sledgehammer will be very similar. And although it's not very practical, they do stand up on the heads like this, which I think is pretty cool, but not practical. Now, just for curiosity's sake, I wanted to see what those spring collars could handle. This is about 66 or 67 pounds on the end, and I'm giving it a couple shakes, not having any trouble with it. But what about the durability of aluminum? Well, I'll let this speak for itself. And as expected, it works for every kind of sledgehammer training you can think of. Front levers, rear levers, face levers, etc. Well, there you have it. A loadable sledgehammer with handles like a gripper. This was a fun project, and I look forward to the next one. So don't forget to tune in next time where I'll